Okie dokie. Look at me, I'm a whole minute early. Well, welcome everybody who's here. If somebody would be so kind as to put something into the chat and let me know you can hear my voice, see my face, see my screen, all that good stuff. And we can get this train moving. Get things moving. And I have a little bit left of my delicious caffeinated beverage. It's an important part of the day. I'm all good. Thank you, Gamester. Appreciate the confirmation. Um, just taking a look at the old notes. Ian's here. Welcome. Welcome. All right. I got a few kind of housekeeping things to start us off with today because we're still in week one, and I know a lot of people are still getting their sea legs. So uh, we'll do a little of that, and then really today though is going to be jump in to the deep end of the pool a little bit. So today we start doing the real kind of class stuff. Last time on Tuesday it was a lot of that was just the syllabus and like how the class is organized and the tools and all that stuff. So my hope is that by this point, near the end of the week, you've gotten your development environment, mostly if not all the way set up. You've registered for the tools. You've started to look at the things, all that stuff, and you've kind of did the what was the first assignment? I don't even remember anymore. It was an hour of code. You did the hello world. So all that, I'm hoping you've kind of mostly knocked that out. So now we really get into the meat a little bit, the first stuff. You have class that starts at 2, so I can't make the whole stream. That's okay. Hey, if you can hang out for the first hour, or first half hour, that's fantastic. Oh, and Dulce is here. Hey, thank you for being here as well. Before I do anything else, are there any questions? If you have any questions about anything that we talked about last time, there was a lot of stuff there. Good time to throw it into the chat now. I'll try to address it. I have a few little reminder thingies I'm going to do, so I'm going to go into that, but then I'll, as always, keep monitoring the chat. I want to remind everybody to watch all the videos. I know, and I said this last time, and I'm sorry. I apologize. I need you to go into first off, you need to do the course overview quiz. If you haven't done this yet, then you will not have access to this. And I've also published the lecture 2 stuff, right? And you won't have access to any of this unless you've done the course overview quiz. Also, if you haven't done the course overview quiz, I'm just going to be telling you right now, if you haven't done this course overview quiz and successfully passed it by the end of Friday, I'm probably just going to drop you because first off, that means there's no way you could have done this, and so or the quizzes. So like from my perspective, that you've kind of just signaled to me like I'm not really taking this class, and I have a lot of people who are like been pinging me to get into the class, so I'm not interested in keeping folks in here who aren't really committed to it. But the other thing I really need you all to go do, if you haven't already, is go watch all these videos. And again, I'm sorry, I know it's a ton of videos. It's just a lot of background information, so just please go watch it. It has a lot of useful information. I'm going to be going through. At this point, I'm kind of expecting you've watched most, if not all of these. So a lot of today will be predicated on you've watched those, and now we're going to go beyond that. Anything else? I haven't seen a lot of traffic on Piazza for this class. So just a reminder, that's the primary place I want you to post questions about the class. I have had a few people who have emailed me or Canvas inboxed me questions that are like, how do I set up my development environment? And I'm just like, that's a class question. That's something that other people would need to know. So that's a Piazza question. You should put that in Piazza. You should. So if it's something that like you're probably not the only one, and that's something you're going to have to get kind of comfortable with, is if you're having a technical problem, I don't know how, you're not special. You're not. Most of the people are going to have a technical problem. So the sooner you post that into Piazza and let me or somebody else help you out, you're just benefiting everybody. So don't be afraid of it. It's there to help you. post it there. And also check there. If you're having a problem, I would check there first because there's a good chance maybe somebody else has posted it and then you're going to be the recipient of that already vetted answer. Um, and also be sure to read all the directions for the assignments. We're going to talk about that here in a minute, so I'm not going to go through that much more. Um, and the other thing I want to mention, um, this class, I think I said it last time, it's a tough class. This is not an easy class. It's going to be hard. So a lot of students don't take CSCI 4. If you've taken CSCI 4, I find that this class, you've got a little good starter. You've covered a lot of these same topics in a different language, but you're familiar with a lot of it. So the first maybe I don't know, half, I don't know, a quarter at least of the semester, you're gonna feel pretty cozy. If you haven't, and this is literally your first time doing programming, you're gonna need to knuckle down and really not fall behind. But some people, for whatever reason, they get in this class, they're a couple weeks in, they get them, whatever, and they're just like, this is not for me. I don't like this. It's too fast. I don't like this guy. I don't like YouTube. I don't like how it's organized. Whatever. There's lots of. I have a thing going on right now that I have to take care of, and I can't concentrate on school. That's okay. The computer science department recognizes that, and so if you've not taken CSCI 4 already, if you don't know what that is, that's our introduction to programming class. It largely covers the same material as this class, except like a subset of it. It's like slower, less intense. I think I always kind of refer to it as like the gentler introduction to computer science. Um, but the reason why we offer it is because it's helpful for folks who want to have a little gentler start before they get into this class. This class is a prerequisite for CSCI 21. So if your plan is to take CSCI 20, if you're a computer science major and you're gonna go that way, this class is a requirement. You're gonna have to take it at some point. Okay, so a lot of people, they just want to jump in and do it. Makes a lot of sense. But if you get here and we get maybe another, I don't know, a few weeks in and you're just like this, I'm not feeling it. I'm not doing a good job. We do offer a late starting CSCI 4 class. So I just want you guys to be aware of it. It starts in, and I wrote it down here, it starts in late September. So it starts on the 25th of September. So, I mean, you got like a month to figure it out, right? So if you're in this class, so I suggest stick it out for at least like 3 or 4 weeks. If you get to the end of the third week and you're like, I don't want to do it anymore, then that's kind of a nice little off ramp for you. I would then probably suggest trying to enroll in that class. You will not miss a single thing, right? That class doesn't even start till the 25th of September. So hopefully you can get in there and then maybe you can get that gentler introduction that might be a little easier. So then when you take CSCI 20 at a future date, you'll be a little more prepared for it. So I just like to advertise that to everybody. That the late starting one this time is going to be, it's an in-person class. They're going to have it at the Chico Center. So that's the only thing. If you need to be online, then maybe that's limited. I don't know. What I don't recommend to anybody, and I always like to tell everyone this, don't take CSCI 4 and 20 at the same time. I don't think it's a good idea. Like I said, they cover a lot of the same stuff. If you take them concurrently, I think it can get confusing for folks. Because then now you're really trying to learn two different programming languages teaching roughly the same stuff at different rates. It can be it's not good for learning, in my opinion. So I would suggest doing one or the other. I think that we have a degree, I don't remember which one it is, that requires both. It actually requires CSCI 4 and 20. So sometimes people take them at the same time just so they can get through the program faster. If that's your situation, I guess that's fine. Go ahead. From a learning perspective, I don't think it's very useful to take them both at the same time. I would take one or the other. Okay, that's just my 2 cents. All right. So if there's any questions about that, go ahead and throw it in the chat. But I always like to make people aware of that as an option. Okay, now I can jump into the things. So I'm going to start today off with. We're going to jump into this other. I opened up a new lecture module, right? So this is all the stuff this is the new homework, if you will. All right, so let's go ahead and start off with the example code. This is a module that I publish, and every once in a while, I just need you to know how to do some specific thing, and I'm just going to provide you like a little write-up of like exactly how I want you to do it. Okay, and so the very first thing I always publish is the proper code layout. So let's just go ahead and get in there. Proper code layout is just me telling you this is how I expect your code to look pretty much every single time. Okay? So you can almost think of this as just like the starting point for all of your code that you're going to submit. So I would get in the habit of just like, just copy and paste this directly into your text editor and then start writing your code from there. Part of what is probably the most salient part of this is this part at the top that I refer to as like a header block. That's usually what I call it, as a header block. It has other names. Sometimes people call it like a code header or comment block or something like that. Um, it's a pretty commonplace thing that a lot of professionals do for their for the programming files that they submit. Is they have like a little thing at the top in code that says like what the program is, who wrote it, when they wrote it, what it's about, and it's documentation is what it is. It allows you, future you, who might be coming back and looking at this code, or other people to know what in the world this thing does. And I'm going to emphasize the other people part here because for a lot of you might not know that if you're interested in becoming a professional software developer, which I'm kind of just assuming you all are, you're likely going to work on a team. You're almost certainly going to work on a team. You probably aren't going to be working at a place where you are like the one and only programmer and you just never talk to anybody, I guess, and you're the only one who does that. I'm not saying it's impossible, but it's very unlikely. Much more likely scenario is you're going to work somewhere where there's going to be a team of people and you are going to be looking at code that other people wrote all the time. You're going to be doing that far more often than you're writing your own code from scratch. And college, school in general doesn't do a great job, I've noticed, of kind of preparing people for that because usually you get in school and you write everything from scratch. So when you get into the workforce, you kind of think that's what you're going to do, and you're not. You're going to spend most of your time, like easily 80%, 90% of your time, looking at stuff that other people wrote and like making little tweaks to it. Right. So in that situation, that's why this sort of stuff matters, this documentation stuff. Okay. So we're going to just start off today. So what I'm going to basically do is I'm just going to start us off with hello world. I'm just going to implement hello world. I don't really care if I know it's due technically tomorrow. This is not a I'm not really worried about you like knowing what this does or having it done explicitly for you. This is more about you just knowing like how to get your dev environment set up and then can submit something. This is more just an exercise in following directions and getting it set up than it is in like doing any kind of programming really. So let's do it. And I'm going to head over to, well, here, I'm going to do exactly what I'm telling you should do. Copy. I'm going to come in here, and I think I had you guys name it main.cpp, or wow, I just did that, main.go. And then it's just paste. I just pasted it in there. Oh, I didn't need to do that. Right? And this is just the boilerplate stuff that should be there, right? Okay. Oops, didn't mean to do that. I'm just full of mess ups there. Okay, so this is just the boilerplate code. This is what I'm expecting you to start with. I'm going to go ahead and swing back over here to Hello World because I'm just going to implement it. I'm basically going to do the assignment for you. Again, I don't really care. My expectation is you've got your development environment set up. I am going to go visit Replit today because I think last time I was going to try and then I couldn't figure out how to showcase it. So I'll showcase it today because some of you are going to use it and I don't want you to be completely like unaware of how it works. So yeah, here it is. I open my text editor. That's what I'm using VS Code, right? I'm going to create a new file. I created a new file and I named it here, exactly what they said, main.go. So there, I created main.go. Here it is, right? And I wrote the following. Now, I didn't write this, okay? I just took it from the proper code layout. Hello World is the only programming assignment the entire semester where I don't require this header block. I don't even check for it. I don't care. Right? Because again, that's not the point of it. The point of it was just to get something submitted that like compiled and ran. Right? But for our little example here, I'm going to do this. And now I'm actually going to do this for Hello World so that you get what it's supposed to look like. So what I'm expecting for your proper code layouts is most programs, not Hello World, but for most programs, this is what I'm expecting. You would type the name of the program. You type your name. Also, by the way, these things that are in brackets, this is just letting you know that like it's letting you know that like this is the spot right here where you would put this information. You don't have to put them in between the brackets. I mean, every semester I have people who are putting things between the brackets. It looks weird. Don't do that. This is just a placeholder. It's all it is. The brackets are denoting this is a placeholder. Right? So your name, I'm going to put my name, right? The date you completed it, so I'm going to complete this today. So here we go, 24/23, right? And now for the description, don't get intimidated by this. This is a high-level description I'm looking for. I'm looking for just like the 55,000 foot view of like what your program does. So for this one, for Hello World, it's a program that displays Hello World and my name. Right? That's literally all it's going to do. I'll clean this up a little. Make it look a little nicer, I guess. All right, and there it is. There, and that's a valid header block now. I've done the header block. Isn't that great? Okay, so that's how I want you to start things off. Now let's talk about what this is. Okay, and I was talking about documentation a minute ago, so I'm gonna start with commenting. So I like to start with commenting. It's probably the least sexy thing in programming, but it is by far, in my opinion, one of the most under taught things, and I want you guys to get it right from the get-go. All right. So, what is commenting? Commenting is the ability in every programming language. I've literally never seen one that wasn't this way. Every programming language for you to add documentation in the code that you are writing. Okay. And the purpose of that is to help others who will be viewing this code. And the others in this case might very well be future you. So it's very common for programmers to write code, spend a bunch of time writing a bunch of code, and then have to stop writing the code for that project for some reason. And then they leave for 6 months and go do something else. They work on another project or whatever. And then they come back 6 months later or a year later and they have to revisit that code they were writing. And they don't remember what they were doing 6 months or a year ago. In that case, the comments are your guiding light. So if you've written good documentation in your code, it can contextualize what you were doing, why you were doing it, how the thing is set up, right? And it makes it way easier for you to jump in and actually start modifying it or continue your development without having to like relearn every single thing you were doing, right? So this is an incredibly useful thing. And especially when you're working on teams, and like I was saying, you're probably going to be looking at other people's code. You want them to be commenting their code too, because you're going to eventually have to look at it. And if they literally have written 1,000 lines of code and never commented one bit of it, that's going to be really crummy for you, because then you get to go in and like reverse engineer every single thing that they did. And it's not fun. So this is a big deal. I strongly encourage you to just get comfortable doing this right from the get-go. So the way I'm first enforcing that is always writing a comment block at the top, right? There are two types of comments syntactically in Go, and this is pretty true for most languages. So I'm going to tell you about the first one. The first one is called a block comment. Block comments are when you need to comment out a whole bunch of code. So when you want to do that, you do /*, and they always start this way, /*. So notice as soon as I did that, VS Code immediately turned all this green. That's because now it thinks that everything that came after that is commented out, right? The way you end a block comment is you do */. So everything in between those 2 points is a comment. This is what is a block comment. Okay. Now, I know I've been talking about this, and you might be going like, okay, you keep saying comment. All right, what does that really mean? So from the compiler's perspective, it means don't treat this like code. Like this is not something that you need. You can ignore this, compiler. Right? This is for the human, not for you. Okay, so that's what we mean when I talk about commenting. It's documenting for another human being to look at it. So you should have at this point have watched my compilation and interpretation video, so you have a general idea of how code is compiled and turned into executables, and that's how everything works. So hopefully that's not crazy new to you. But if you have bits in the code that are like just for humans and you don't want the compiler to read it, that's what the comment is for. So notice how when I do this, I can write as much as I want in here now. As long as it's between those 2 points, right? It's fine. Nothing bad happening there. The compiler will just ignore it. It'll just straight up ignore it. Okay? But if I take it outside of that area and I start writing things, well look, now it thinks I'm writing code. It doesn't like this. Wow, it actually started to write a main function. That's weird, right? But it doesn't like any of that. It's going to see how like VS Code's already complaining. It thinks that I'm writing code, and it's like that's not real code, right? So that's the problem. That's why you do the comment. You need to be able to separate, for the compiler's sake, the things that are documentation, the things that are actual code that it needs to go and compile and turn into an executable. The other kind of comment that exists is what's known as a line comment. A line comment only comments out one line in the code. In Go and many other languages, it's 2 forward slashes. Okay, this is what is known as a line comment. The difference here is that only that line is commented out. If I go right below it and I start writing stuff, it thinks this is code again, right? Versus the block comment was for everything in between. Okay, so basically, anytime you write 2 forward slashes, anything to the right of those 2 forward slashes is a line comment, right? Anything to the left of it is actually still valid code. See, it still thinks that's code, but everything to the right of it after those 2 forward slashes, it thinks is a comment. Okay. I pretty much always have my my header blocks as block comments. I use a block. You notice how that's the format I use. You don't need all these extra stars. I do that just for visually. I think it looks nicer. It's easier. It separates this more visually from the rest of it. Okay, but strictly speaking, this is all you need. Right? It's just that 1 forward slash star and then the star forward slash. All right. Any questions about comments? Hopefully everybody's cool with that so far. Okay. All right, so now I'm going to come in here and actually look, you notice in my little starter spot, I even give you, your code goes here. It does go there. And that was a comment that wouldn't have been interpreted by the compiler. So let's go ahead and finish this off, and we're going to do hello world. So now I'm going to go back over here to the actual assignment. I have package main, import fmt. You may have noticed that keeps disappearing. It's because I haven't printed anything. Don't worry about it. VS Code is just trying to do me a solid right now. Right, and I'm going to go ahead and, here, I'll just do this. I will copy this, paste it in here. Is that where it needs to be? Yeah, that's where it needs to be. Okay. Hit save, and now look, it magically reappears. Okay. So this is the stuff it wanted you to do, and then what does it want you to do? It wanted me to change this to Matt. Change it to your actual name, right? So there it is. I did the work. Okay. Then in the assignment, what did it have you do? It wanted you to Control S, which I just did, so I saved it. In VS Code, if you're using VS Code, every time you can tell if you haven't saved yet because there's this white dot that shows up here next to your file. See that white dot that's there? That's letting you know you've made a change to this file and you haven't saved it yet, right? So right now, if I want this to be the way it is, then I have to hit Control S, or I guess I can go to File, Save, which is just Control S. If you're on a Mac, it'd be Command S. And now I have the code saved onto my somewhere on my computer. And now I'm going to run this command in the CLI. And this is going to compile and generate an executable for my code. So here's go build, and then the name of my file. The name of my file right here is main.go. So I'm telling the Go compiler to go build. Build is their way of saying compile. Go compile this and generate an executable. It's going to run for a second. Assuming that there are no errors, assuming the compiler was successful in being able to interpret your code and then turn it into an executable, you'll get nothing back, and then a new line will form. And then up here on the left-hand side, you'll see main.exe. It generated the executable, right? So here's the thing that the CPU can actually run. Main.exe. Hello world, my name is Matt. I'm a genius. I did it. Okay. So that's the assignment. I feel like if you did all that, you run it, this is what should have popped back out. You felt good about it. You went over to AutoGrader. You submitted it. Happy day. Okay? So that's what we're going for here. I'm going to continue on with my commenting journey here a little bit. So another very common use case for comments this is sort of just something you learn as you go. It's like a trick of the trade. The primary benefit of a comment is for documentation. It's the main reason this exists. However, they also serve a very useful function when you're debugging things. So what does debugging mean? When there's a problem with the program you're writing, and you're trying to figure out exactly where that problem is, it is convenient to use comments to help isolate the problem. Let me demonstrate that. So let's say that this is my very sophisticated program, these two lines here, right? Let's say I thought that there was a problem with the second line, right? I was like, this line's having a problem. I don't know why it's having a problem, but I think this line is working fine. I think everything's fine here. I'm just trying to figure out what's going on here, right? So when I run this program, maybe I don't want this to even happen. I just want it to go away temporarily while I spend my time dissecting this, right? Well, this is a great strategy that programmers use is they will comment out some of the code, right? And hit save. And this also will demonstrate that it just gets ignored, right? So now when I run it, I'm going to build it again. That will generate the executable and overwrite the previous executable. And now I run that. And notice how now it just says my name is Matt. It didn't do this. See how hello world never was printed? It just ignored that line of code because I commented it out, right? And this is a very common strategy when you're trying to isolate code to just comment out the bits that you're not worried about at the moment, and then you can focus your attention on the part that's having a problem, right? This is superior to having to delete the entire thing because then you have to save it, run it, and then when you want to put it back, you'd have to remember whatever it was that was previously there. So it's nicer to be able to just comment it out and then be like, oh, okay, yeah, that works, and it's still there, and all I have to do is just uncomment it, and then it's back in action. Okay. I think I've beat that horse to death. Any questions about comments or their use cases? I would recommend early on, while you're here in this class, comment everything. It's a bit of an art form. There is such a thing as over-commenting, but I would say that rule does not apply in your first semester of programming. I don't think that you're going to overdo it commenting-wise. I'm never going to grade you down because you wrote War and Peace into your source code. If that's what you needed to be helpful for you, then do it. Do it. You're learning everything right now. Do yourself a big solid because you're probably going to come back to these programs later on in the semester and you're going to want to be able to know what in the world you were doing at that moment. So for me, a good example of a comment, say display text to the terminal. Here, I comment. So this comment is letting you know what this stuff is doing right below it. Right? This is a really typical thing to do. Me, as a seasoned programmer, I would never do this. Why? Because it's really obvious to me what this is doing. I don't need that extra context. Okay? So that's when I say it's kind of an art form. Some people will comment a lot. Some people will comment a little. Good rule of thumb, in my opinion, if it seems like it's a little complicated to you, probably should be commenting it. Right? Once you get a little further down the line and you write some code and you're like, that's not obvious. It's not obvious what this is doing. You should add some comments there, right? If it's super obvious, like literally one line of code that just puts something onto the terminal, maybe you don't need to do that. But for now, I would say just do everything because everything's new to you right now, right? And it'll be useful to you. It's a good habit to get into. If you've been doing it all along, then you'll just keep doing it. If you never comment and then at some point 3 semesters from now you barely start doing it, you're not going to be very good at it. Right. All right. That's all I'm going to say about it. I know I've beat that to death, but that's a really important thing. I don't feel like it gets the love it should. Oh, by the way, this is another good thing. I wrote this in my notes. All the code that I write during the class, I don't know if I said this during my last lecture. All the code that I write during my lectures, I post on our Canvas shell. So I didn't do it this last week because I didn't write any code. Right. So here's the link to last week's lecture, on Tuesday's lecture is right here. Normally this will show up in the lecture 1 area. I just have it here because some people haven't done their course overview quiz yet and I wanted them to still be able to get to it. Right? But at the end of this class, you're going to see lecture 2 live stream show up here. There'll be a link to it from here. And then you're also going to see lecture 2 code. And there'll be a page there where you can download all the code that I write today. So I do that every week. So don't worry if you didn't write down exactly what I wrote down. You'll have access to it for the rest of the semester, okay? Just want to reassure you that you don't have to wig out too much. Okay. We did proper code layout. Okay. And we've done some commenting. So now let's talk about, we're going to take a journey away from the code for a little bit. We're going to go over to my good friend OneNote. And you get to watch me draw. That's the best. So I have a question for everybody. Hopefully there's some folks still on. Hopefully everyone hasn't left the room yet. Okay. I have a question for those who are participating. Thank you for being here. What is the difference between these two things? This is a generic question. I am not trying to trick you. I'm not even necessarily talking about computer science at this point. Also, I'm demonstrating how bad my handwriting is. But generically, what is the difference between long-term memory and short-term memory? That is what I am asking you. Okay, just a generic, there's some difference between them, right? What is it? Every time I ask this question, everyone thinks I'm trying to trick them. Like, why would I do that? I don't understand why. What's my motivation for doing that? Oh no. Well, it could be the lag. So a lot of times I ask questions and then I have to wait upwards of 15 seconds before you guys even hear it, let alone, when you respond to it. Anybody have any ideas? It's as dumb as it sounds. It's as dumb and as simple as you would think. Oh no. Nobody knows? Am I the only one here? Actually, I have no way to. It tells me. Looks like I still have a few people on. I like that. Yeah, they'll say it's something you said 2 seconds ago compared to something you said 2 months ago. Perfect, right? It has to do with how long something is around. So, in computer science and programming, there's a difference between long-term and short-term memory as well. Okay? Long-term memory, which is oftentimes denoted with this little cylinder thingy, right? This is just pictorially how they often are. It's often drawn. An example of long-term memory would be, for a computer system, would be a hard drive on your computer. Okay? So that's an example of long-term memory. So the point here being is that that's where you put things when you want it to be there 2 months from now, right? Like you were just saying. It's there for a long time. Now, second question, and it's fine if you don't know the answer. What is the short-term equivalent in a computer system? Where's the place that we keep short-term memory on a computer? So your hard drive of your computer is long-term memory. What is the short-term memory? Does anyone know? I just need time to drink my drink. There's not a lot left though. Not a lot. Sorry, I'm just reading my notes while somebody says something. All right, it's fine if you don't know. It's okay. Don't feel bad. It's not like a huge deal, right? So on a computer system, short-term memory is RAM. Okay? And it doesn't really have a picture. You just say RAM. Okay? RAM stands for Random Access Memory. Okay? Oh, I misspelled memory. Well, all right, whatever. Oh, no, I didn't. They're fine. Okay? Random access memory is the memory on a computer system that is short-lived. Okay? So, the example I always like to use for distinguishing between these two things, let's say you were writing an essay, right? You're writing your essay for your English class or whatever, and you have a word processor open. You're all using Microsoft Word, right? Word, right? Man, my handwriting is terrible, right? And you got all this stuff written down, and it's beautiful, right? Here's your Word document that you're writing, okay? Now you've been writing a few paragraphs, you've got a good clip into it, right? But all of a sudden you're like, oh no, I don't want to lose this information. What do? You've written like 4 or 5 paragraphs. Now what do you want to do to make sure that that information doesn't go away? What do you do? What do you push on your computer screen? You're like, oh, I don't want to lose this. I've written too much. I don't want it to disappear. Oh no, it's already second class and I have a low turnout. I wonder if I just picked a really crappy time. I might have. I don't know. Hopefully not. If you're writing stuff on your Word doc and you don't want it to go away, what do you do? How do you keep it so that it doesn't go away? Oh man, I might have to just I might just have to turn this into the class where I answer my own questions. Oh, Dulce, you're my friend. Save. Of course, you save it, right? You usually hit like Control S, right? When you do that, and you're like, oh crap, I don't want to lose this information, you hit Control S. What you're doing is you're taking the information. So Microsoft Word is a computer program. It's a program. While Microsoft Word is running, all that stuff that you're writing into the document, you know where it's going? It's going here. Short-term memory. When you turn off Microsoft Word, all of that goes away. It disappears. The computer just throws it away. It forgets all about it. It's just like short-term memory, right? It's something where it's only there for a little while and then you forget about it. Okay? So if you don't want that to happen, then you do the operation that Dulce just said. You say save, and what you're basically doing is you're transferring that information out of RAM and into long-term memory. And that's usually when you have to pick like a file that you want to save it to, right? You put it somewhere on your hard drive, or maybe you put it on a network drive, or like the more modern equivalent now, you'd be putting it in like a cloud-based service, right? You'd be putting it into OneDrive or Google Drive or whatever Apple does, I don't know, right? Like you put it somewhere, but it's going to be in the form of a file. It's going to be form of that information. And then when you want to then after you've saved it, right, then you can close Microsoft Word, right? All the stuff that was in RAM goes away. But then if you want to open up Microsoft Word again later, you can retrieve that information out of the hard drive and you can load it back into Word. And what it's basically going to do is going to take that information out of the hard drive and load it back into RAM so that you can continue to use it. So that Microsoft Word allows you to continue to do whatever it is you're going to do. So that's the big difference here. That's the difference I'm talking about. Now, I'm not going to ask this rhetorically because we're getting low participation, but I appreciate you, Dulce, because you're my friend right now. In this class, the vast, easily 95% of the time, the kind of memory that we're going to be using is, oh my goodness, where's my cursor thingy? Is RAM. Okay, we're not going to be using this very much, right? RAM is the memory of computer programs. All the stuff we're going to do for like most of the semester lives right there. I'm just making that distinction because it's not a place that most people are kind of familiar with files by nature. Not everyone is familiar with RAM. You know you want a lot of it when you're buying your computer, right? But you don't even really know why. But that's it. That's what it is. Okay, so now let's talk about what is RAM. All right, so what is RAM? What is this thing I just mentioned? So for that, we get to go to my spiffy diagram that I've already drawn for you. Okay, so RAM is hardware on your computer. It's a physical stick that you plug into the motherboard of your computer. That's what RAM is. It's a physical thing. It's just like a hard drive or a keyboard or it's like a physical thing. You can touch it. Okay? RAM is comprised of two things. It has two parts to it. RAM holds addresses, and each address holds a value. I have this other row here, and we'll be using that later just for simplicity's sake, right? But these are the two things that RAM consists of: addresses and values. That's all it has, right? The addresses are physical locations on that RAM stick. They are actual physical locations. They exist at very specific spots, right? And the way that those addresses are represented are by big numbers. Now I have drawn small numbers on my diagram because I can't possibly draw the numbers big enough for our diagram. But for simplicity's sake, you can just think of them as these small numbers. But realistically, they are ginormous numbers. They're very, very big. Okay, and each one is like a location on the RAM stick. Right? So this is address location 100. At address station 100, there is a value. At 200, there's another value. At 300, there's another value. Okay? That's how RAM is broken up. Now, I'm not going to ask this question rhetorically because I don't think I'm going to get a good answer because it's a hard one. Most people don't know this, right? when you have a computer program, so let's say this is your program right here. It's a beautiful program. You wrote it in, I don't know, who cares what language? It doesn't matter, right? Your program ultimately has to talk to RAM. Like we were just talking about this, right? We were just my Microsoft Word example, right? Obviously, your program is putting information into this physical thing, right? So now the question is, how does it do that? How does this thing that isn't physically connected, it's a program, it's running on the CPU, like how does it interact with the physical components of your computer? And most notably, the thing it interacts with most is probably RAM. How does it do that? Well, there is an intermediary. Your program does not directly talk to RAM. It doesn't do that. Very few programs directly talk to RAM unless you're building like some very highly proprietary embedded system thing, right? The vast majority of computers, the programs running on them, do not directly talk to RAM. Instead, they talk to the operating system. And I'll put a little cloud around it to make it seem fluffy and nice, right? Your program talks to the operating system, and it basically requests space in RAM. Now, the reason it does that is because this RAM is shared by all of the programs on your computer, right? These are all programs. They all need RAM to do what they're doing, right? And they all are having to make requests to the operating system. They're all like needy children. They're like, gimme, I need space. Give me my stuff. And your program is no different. Your program's like, I need space to be able to do what I want to do, right? Okay, so this is sort of the architecture. And you might be asking yourself, like, why are you talking about this, man? This is a computer science class, not a hardware class. If you don't understand how your program interacts with the hardware on your computer, it is impossible, frankly, for you to ever write efficient programs. You need to understand this. And the thing that RAM is never going away. This, what I'm describing right now, is completely independent of any language. Every single program on the entire planet works this way. It doesn't matter if you're using C++, it doesn't matter if you're using Go, it doesn't matter if you're using Python, all of them do it this way. All of them, right? They all use RAM. RAM is where they store it, right? So your knowledge of how your program interacts with this incredibly important piece of hardware for you is a big deal. It's important, right? So that's why I want to start us here before I ever start talking about code, right? I want you to understand what's actually happening and what your code means under the hood. So the most common thing that your program wants is space in RAM. So usually what your program's asking for is a specific amount, saying, I need this much space, please, because I need to store a certain kind of piece of data. I need a certain amount, right? So for simplicity, I'm going to say your program needs an integer, right? So your program asks the operating system for an integer, and the operating system is the only thing that actually knows who's using what in RAM. So the operating system looks up here and says, hey, nobody's using address space 100. You can use address space 100. I have allocated that one just for you, program. I'm going to call your program A. You get it. Program A gets address space 100. Right? Nobody else is allowed to use that while this program is running. That's what the operating system is doing. It's like the hall monitor. It's like the parent in the room. It's the one keeping track of who's got what. Right? So once it's been done, program A now knows I get to use address space 100. Okay? Except that would be really crummy for you because like I said, the address spaces are these really big numbers and it's really hard to keep track of really big numbers. So instead, what like nearly every programming language in the world does is they come up with a way to make it easier for you as a programmer to keep track of all of these address spaces that your program has been divvied out. And that is what we call a variable. So let's talk about that. Make a new program. By the way, so I have a little macro or a little snippet or whatever the heck it's called in VS Code. So you notice that I can just do a little thing and it just immediately built me my proper code layout. Okay, you can do that too. If somebody puts something up in Piazza, maybe I'll share how you can do that if you're using VS Code. All right, so you notice how this just automatically built it for me? Nice, right? Let's talk about variables. So all of that I just talked about, that relationship between your program and RAM, I'm going to show you how you do that in code now. Here it is. Pay close attention. It's really complicated. There it is. I did it. That one line tells the Go compiler to create an executable that when you run will tell the program to reach out to the operating system, request an integer's worth of space, right, and retrieve it back. And when it retrieves it back, it knows it has address space 100. How does your program know what to call that? Like, how does it know what that number is? It creates what we call a variable. This variable is just a nice representation of that address space. That's all it is. It's just a special little symbol that you get to define that really just means address space whatever on RAM. That's what your variables are. Your variables are intrinsically linked to RAM. Now that I have this variable, we talk about how you declare them and how you create them in Go. This is the format that Go likes. This is just a syntax that, every language has their own way. Declaring variable, right, in Go. Okay. So what they like, Go likes you to start with the word var. Not every language does that. Go does. Okay. You start with the word var, you put a space after that, right? Then you put the name of your variable. You can name your variable pretty much whatever you want. There are some variable naming rules. There are some certain things. I'm going to have you look those up as part of some homework eventually. But for today, just recognize that by and large, you can call it pretty much anything you want outside of a few different rules. You can't have like spaces in them and stuff like that. All right. After that, you put the data type. Okay. If you don't know what a data type is, don't worry. I'm about to talk about it. Okay. But this is the the format that you need to use in Go to tell the Go compiler, please set aside some space in RAM for me, and whatever that space is, I want to call it this. Okay? All right. Let's talk about data types. In this class, there are basically going to be 4 data types that we use, right? Or that Go gives you that we're going to use. Here they are. Int, and what an integer is it can hold integer data. Float 64 can hold floating point data. Bool can hold Boolean. If you don't know what Boolean means, that's just true false data. And string. Can hold a series of characters. These are the 4 primitive data types in Go. Now technically there are more than this. If you start Googling primitive data types in Go, you're going to get a list longer than this. Okay, they have a bunch of other ones. These are the 4 that I'm going to use. Okay. This is not a Go class. I'm not overly interested in finding out every little esoteric thing that the language has, and I don't really care. I just want you to know the basics. And pretty much every programming language is going to have these 4, right? They're like the fundamental building blocks of almost any kind of program you're ever going to use. So those are the ones we're going to use. Why do I call them primitive data types? They are primitive because the Go compiler has already been programmed to know exactly how much space to ask the operating system for each one of those types. So when I said var myvar int and I hit compile, it knew how much space an integer was in RAM. I didn't have to tell it that. The compiler just knows. It knows exactly how much space to ask the operating system for. Right? For all of these types, that is true. Okay? So here, let's go ahead, and I'm going to go ahead and do it for each one of them. We'll do var my int And I'll go ahead and initialize them, and I'll talk about that in a second here. Set that equal to 42. And then actually what I'll do is I'll print them out. I have to print them out because Go is a little bit like persnickety about this. Ah. Let's do that, and then we'll do my int. Looks great. We'll do the second one here. We'll do a float. Var my float, float 64, and we'll set that one equal to, I don't know, 3.14 for pi, I guess. Why doesn't it want to? There it goes. My float, great. Next one will be var my bool. You're going to have to put up with a lot of my bool this semester. We'll set that one equal to true, right? My bool. And well, the last one, certainly not the least one, this is probably one of the most important ones in the whole thing, my string. It's a type string. We'll set this one equal to hello world. My string. Oops. There we go. Okay. And then I'm going to get rid of this one, since all I was doing there was demoing what it can do, but this is also doing that. Okay, so here we go. These are the primitive data types in Go, and here's a little example of how you would declare each one of them. Okay? Any questions about that? You guys are being awfully quiet. Any questions about how you would declare these variables or what they do? Right? I'm going to run this now. Now, when I did this in main, and how I had you set it up in Hello World this for tomorrow's homework, I had you guys running Go build. Okay? I did that because I wanted to emphasize that it's a two-step process. First, you have to give your code to the compiler. The compiler will then generate an executable, and then you run the executable. So it's always compile and then run it. Compile and run it. Compile and run it. Okay? They're two distinct steps. However, the folks over at Google who make Go, they recognize that that's like a really common operation. You're doing it all over again. So they built a little neat thing into their compiler toolchain, right? They made a little feature that lets you do both of those steps at once. And so you're going to pretty much see me do that for the rest of the semester. So here it is. If you want to do that, you can just say go run and then pass it the name of your file. Not the executable, but the file. Your actual code. Oh, and I want to do variables actually. There we go. So go run variables. And what does it do? It compiled the code. It generated an executable, and then it immediately ran the executable, which is why I have this stuff popping out in the terminal. You also might notice that up here in the folder, you're not seeing like variables.exe. That's because that's something else that this neat little function here does, is it sort of just puts it into a little temporary spot so that it doesn't have to clutter up your folder, right? So now that I've done that and I've showed you that I'm going to keep doing that, by the way, look, when you look at an executable, see how you can't actually open it? It's formatted for a CPU. It's not formatted for you. I'm just going to get rid of that guy. All right. So this is pretty much how you're going to see me run programs for the rest of the semester. Every once in a while I might do it differently to demonstrate a point, but for now, this is just a really simple way to do it. And you can see exactly what happened when I ran this this program. Let's get out of that guy. All right. So I created the variable. I printed the variable. I created the float. Printed it, created a boolean, printed it, created a string, printed it. And here they all are on the terminal. Any questions about variables or how they're declared, how they're stored, their relationship to RAM? So quiet. No comments. It's okay. Just give me a second for if anybody does. That's a good question. What does the 64 and float 64 mean? So technically, there are two types of. Well, actually, it's a good question because it's getting to the point of what the relationship between your variable and RAM. Like I said, each one of these data types takes up a different amount of space. Okay. By default, an integer is 32 bytes. It's a 32 byte value. By default, like in most languages, they don't do this 64 thing. They have a float, and that float is 32 bytes as well. A Boolean is usually like 8, and a string is, well, strings are dynamic. They can get as big as they need to get. So by default, that's what it works in most languages. In Go, they actually have two different kinds of float. So if you want, you can actually make a other float, float 32, right? And that's a 32 byte one. Okay. This, or actually, it's probably 32 bit is really what I should probably be saying. Yeah. This is another option. I'm having issues float 64 because later on in the semester, we're going to need to use the 64-bit version of it. Okay. For now, don't worry about it. Just recognize that it's a data type, and the main difference between a float and an integer, in case you don't know what floating point means, this one can hold decimal values. This one can only hold whole values. So on a practical level, that's the only reason why you would probably declare one or the other type, is that if you know the kind of data that you're going to hold, like has fractional values in it, then you're probably going to want to use this data type. If you know it's going to hold whole numbers, then you probably want to use this data type. That help a little bit? But yeah, the 64 is just talking about the size. So the float 64 can hold literally twice the amount of value as a float 32 can. That's a kind of a Go specific thing. Most languages, they just default it to 32, and you don't put a number in there. Okay, I think that's good. Good question. Let's see here. Let's talk about initialization. So, when I declare these variables, there's sort of a two-step operation happening. This part right here that I have highlighted, that is called a declaration, right? That part is the part that's telling the Go compiler, go ask the operating system for space in RAM. Go ask the operating system for this much space in RAM, for an integer's amount of space in RAM. Okay? This part to the right of that, though, that's something different. This is called initialization. So on top of saying, give me some space in RAM, I'm also saying, once you give me that space, this is the value that I would like you to immediately put into that space. So right at the moment that you get me that space in RAM, I want you to put this there. Okay? Now, visually, the way we have set this up right now, these are the variables. I'm going to kind of draw a parallel between that and how I set it up in RAM. So let's pretend, this is just for pretend, let's pretend each one of these columns was exactly one of those variables. That's a completely unrealistic thing, because it's not like an integer is only 100 spaces away from float, which would be 100 spaces. Like, they will be next to each other, but they certainly take up different amounts of space. But just for visual sake, I'm going to put them like this. So for this case, let's say that the integer, that the my int variable is at address space 100. There's my int. Here's my float. Here's my bool. And here's my string. Okay? So what I did was I said, okay, right when you give me that space, put a value in there. So what would happen in RAM? This would have been the 42. 3.14. True. Hello world. Okay? That's what I basically just told this program to do. Right? That's how it'll store it in RAM. However, if I had done this and not initialized it, okay, what would have been stored there? So now the question is, I didn't put a 42 immediately in there, so what would be in there, right? Okay, so in most programming languages, the primitive data types has a default value. It's not true for every language, and I'm looking at C and C++ on this one. They actually don't have a default value, which is like a whole thing. It's like a whole big thing in that language. But in most languages, like Go, it's a modern language, they have a default value for all the primitive data types. So the default value for an integer, if you don't immediately put something in it, it will by default put 0 in there. And that's just something that the Go compiler is designed to do, right? So you can do that. Now let's say I've declared the variable, but now later on, I actually want to change it. I don't want 0 in there anymore. I want my 42 because that's the best number, right? So what you can do is you can do my int equals 42 later. And at that point in the program, it will update this. It will no longer be 0. It will be 42. Okay? So the way that the compiler generates an executable, when the executable is running your code, what's going to happen is it goes from the top down. It's just like in English reading a book. You start at the top left-hand corner and you read across and then you go down. I guess for you guys it'd be this way, right? It'd be like that, okay? So the compiler is going to start up at the top, and this first line, it's going to go allocate space in RAM. Then, so on by the time line 17 got done running, I would have a 0 here. That's what would be there on line 17. By the time line 19 got done running, though, now we got our 42 in there. Okay? So RAM is constantly having values moving around, getting changed all the time. That's what RAM's all about, and that's how it's able to keep track of what the program is doing at any given moment. Okay? Important thing to understand here. So this is the declaration. This line right here can sometimes be confusing, and more specifically, this symbol right here sometimes gets people. So I'm going to go ahead and zoom in on that so everyone hears me say this. I'm going to say it once, I'm going to say it twice because it's going to confuse somebody. This is what is known as the assignment operator. It is an operator. Okay? So the equal sign, that symbol, in Go and frankly pretty much every imperative programming language you're ever going to use is the assignment operator. What the assignment operator does a very specific thing. It takes whatever is on the right-hand side of the operator, it will evaluate it, copy it, and then move that copied value into whatever is on the left-hand side of the operator. Okay? I'm going to say it one more time because this is important. The assignment operator takes whatever is on the right-hand side of the operator, copies it, and moves that copy into the left-hand side of the operator. Okay? The equal sign, the assignment operator, is not the same thing as it is in your math class. It is not the equal sign for equality. It is not saying that these two things are equal. That is not what it does. There's a whole different symbol for that in programming. This gets a lot of people every time. Just to prove that that's what happens, I'm going to do something. 42 can definitely be moved, or it can be copied and assigned to this variable, because this variable represents a place in RAM. This variable represents, in my little drawing, address space 100, which has a place that you can put it, right? 42 is just a number. It's a constant. It does not have a place in RAM. This is just a constant value, okay? Therefore, if I tried to do this, you can already tell VS Code is immediately going like, no, you can't do that. Why? Because the assignment operator's whole mission in life is to take whatever is on the right-hand side of it and try to copy it and assign it to whatever's on the left. I can't put things into a constant number. A constant number is a constant number. 42 is 42. Okay? So just keep that in mind. That's what this symbol always means. It always means take what's on the right and put it into what is on the left. And more specifically, it's a copy of what's on the right. So, when you put it right next to the declaration, you are saying, copy this and immediately put it into this space. If you do it anytime after that, then it's just assignment. So we have a special name for it when you do it when you're declaring. It's called initialization. So what this is doing right here, this is initialization. What I'm doing right here, that's just assignment. And you can do that as many times as you want. After you've declared the variable, you can use it all day long. You first have to declare it, because that's telling the compiler, give me a spot in RAM, and from after I know what that spot in RAM is going to be, I can do whatever the heck I want with it. All right. Any questions about that? Okay. Not that I would know immediately, since our lag is laggy. Let's move on. And like I said, all the primitive data types have default values. I think the integer is a 0. Float is 0. Boolean, I want to say, is false. And string is just an empty string. So it's a string that has nothing in it. Let's see here. Assignment operator. All right, let's move on. We're moving on to output.go. Okay. So this is basically all things related to variables. And again, I'll give you this code, so don't stress on that part at least. Um, I've kind of been doing this, but I haven't really explained it up to this point. So now we're going to talk about how do you make your program put things out onto the outside world so that other people can see it. Okay. So you've seen this already a few times. There's basically three functions that you're going to see in this class that you can use to push things onto the terminal. You're free to use whichever the three you want. AutoGrader doesn't care. I don't care. I can tell you which ones I'm going to use all semester when I'm writing code, but technically you're free to use whatever you want. So I'm just going to write them all right here. And I'm going to do hello. I'm going to just do hello world about 3 different times. Printf. And okay. So there's that. These are the 3 different ways in which you can push information to the terminal. So this thing that down here, this is the terminal. Hey, look, even VS Code even calls it that. It's a terminal, right? There's a command shell running behind that, right? So this is my little interface. If you watch the CLI video that hopefully I prescribed and hopefully you all watched, that's what this is. This is just a terminal so that I can interface with the operating system basically, and I can tell it to run programs like the one I'm writing. Okay. So these are the 3 functions. There's println, there's printf, and there's print. Pretty much the entire semester you're going to see me use this guy and occasionally use this guy, and you're pretty much never going to see me use this one. I will demo it today in case you want to, but it's not my cup of tea. So I'm going to run this really quick. Go run output, and you're going to see some interesting stuff happen. Here's hello world. Okay, that came from this one. And I'll move this up so we can see it a little better. So when this line of code ran, it made this happen on the terminal. When this line of code ran, it made this happen on the terminal. And when this line of code ran, it made this happen on the terminal. Now, interestingly, you can see there's a little weird thing happening here, right? Why are these 2 right next to each other and this one on top? Okay? I have them all stacked on top of each other in the terminal on my code. Why did they come out this way on the terminal? So this is my way of demonstrating to you there is no relationship between your code in your editor and how it shows in the terminal. I can put as many spaces as I like in here. It will have exactly 0% to do with how it shows up on the terminal. All right? They are not related to each other. What these functions do is they let you very specifically designate what things are going to what is known as the output buffer. Now, I'm not going to get into the output buffer today too much, other to say that you can think of it as basically like one giant long string, just like one big string. And all these functions are doing is you're allowed to push information into that big string in the order that it gets pushed in. And when it's all pushed in there, at some point, it's going to then push it all over to the terminal, and it's going to do it exactly as everything in that string. And it really is just like one long string. That's all it is. Okay? So what's the difference between these 3? Well, println stands for print line. Okay? And what it does is everything between these open and closed parentheses, everything between here, will be printed to the terminal. And then this function will automatically attach a new line character to the very end. Now, what is a new line character? You can think of it like hitting the enter key. You can think of it like hitting the enter key on your keyboard. When you're writing in like Notepad, right here, it's just like if I'm writing in just like a regular old word processor and I do blah, 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 and then I hit enter, right? And I hit blah, 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 enter, it goes to another line, right? That's a new line. Technically, that is its own character. New line is an actual character, just like T is a character, right? It's a character that gets actually printed to the terminal. But the terminal knows how to interpret that. The terminal knows, oh, whenever I see that special new line character, that means to just start on a new line. That's how it displays it, just like how it knows how to display an H to look like this, right? So that's what you have to kind of get your head wrapped around, that like it's an actual character that you're printing out to the terminal. And this function automatically attaches that character to the end of whatever the heck it is you put in here. Okay? These two functions, they do not do that. They do not attach a new line character to the end, which is why after this first one ran, I got this, and then a new line was attached, so then we started on the next line. But then it did this, which was this line bit right here, and then no new line was attached, so as soon as you started printing the next thing, it just picked up for where the last one left off, and it went right here. Okay? So sometimes, so this is why you're going to oftentimes see me use this. It's a convenient function for letting me just format my output because it's automatically attaching that new line. If I want to do my own new line, if I want to do it on my own without having to rely on that function, you can do that, and you can totally do it with these other functions. You just have to do it manually. So the most common way to do this is with a special escape sequence called \n. The backslash, when you're inside of a string, so a string is whenever you're between two, when you have an open and close double quote like that, this is what in programming is known as a string literal. You're basically saying, whatever I put between these two things, that is literally what I want you to put onto the terminal. That is literally the text. That's what literal means, okay? So between those two, that open and close double quotes, right? So two double quotes, if you put a \n, it interprets this as a special character that we call the new line character. And if I put it right here, so this one gets automatically, this one now I've put it at the very end of the second one, right? So now if I run it, look what you get. Hello world, hello world, hello world. Right? I appended it to the very end. If I put another one there, now it'll have two new lines at the end of it. First one, second one, and then new line, which put me here, and then another new line, which put me here, right? So there's no relationship between how it looks in code, like how you've actually spaced it out in code, and how it shows up on the terminal. There's really not much relationship. All of this is happening here. Okay? The output is how you do it. The output, the print lines and the prints. That's how you do it. Okay, so that's the main difference between Println and these other two, is that it automatically attaches it. Now I'm going to talk about the difference between Println and print, because those are the two that you're going to see me use the most. The other thing you can do with Println is you can, between these two quoted parts, you can actually put a comma, and then you can actually have more stuff. I'm going to say my name is Matt. Ooh, is Mol. Right? If you do that, notice how I have a string literal and then another string literal. It'll just put them right next to each other. So you can actually attach many things in a single print. Hello world, my name is Matt. Now here's an important thing to notice. Notice how it's very specific here. This is the opening, double quote. All of this is between that, so that's where I had. But look, there's no space between the end of this world and the beginning of my. And yet, when it got printed out, there is a space between the two. Right? Now I'm going to come down here to print. I'm going to do the exact same thing. My name is Matt. Okay? It is set up exactly the same way. Right? Hello, world. My name is Matt. Hello, world. No space between the D and the M. Right? So that's the other very subtle difference between what Println does and actually what Printf and print do. Println, if you put this little comma to kind of connect two different strings or two different things, it'll automatically insert a space between them. Print and Printf won't do that. Right? It'll give you exactly what's that. So if I wanted to put the space between them here, I'd have to do it myself. I'd either have to add the space there, or I'd have to add the space there. If I do that, and then run it again, now it'll look exactly the same. Okay? All right. Let's move on to, let me see. Any questions about that? Any of that I've done so far? You can add variables here. So we were just talking about variables a minute ago. Okay, so now let's say I had some information. I don't know, some number. Of course it's 42. I'm always going to use that, right? I forgot to put the data type. Okay, so now I've created a variable. I've declared it and initialized it. This is the name of my variable. If I want to use the variable, I can actually use that variable by putting it in places where it can be evaluated, and then its value can be used for something. So in this case, I'm going to put it right here. It's going to be a silly looking, but I can do it. So now this first thing that's going to happen, the first line is going to say hello world space the sumnum. So sumnum is not a string literal. Notice how there's no double quotes? So the double quotes is how it knows you're trying to do a string literal. When it doesn't see double quotes, then in programming that means, oh, well, you're giving me a variable, you're giving me something else that I need to interpret to figure out what the actual value is. And so what is the actual value of sumnum? Well, it's the value that I assigned to it. It's 42. So this is going to say hello world 42 space my name is Matt. Right? There he is. You can do the same thing down here. I'm going to put these back to this. Sumnum space my name is Matt. But because I got rid of those spaces, right, they're going to all be scrunched together again. Hello world, immediately a 42 next to it, and then immediately my name is Matt. Right? Sometimes you want the things to be right next to it. So that's why sometimes you'll see me use print. Sometimes you don't want that. Oftentimes you don't want that. And Println is great. Okay? So I'm just trying to showcase some of these subtle differences between them. As I was saying, these are the two you're going to see me use pretty much the whole semester. I will now talk about Printf, sort of the weirdo in the group. What is Printf? Printf has a completely different setup. It's set up very differently than the other two. Printf is very much like if you were a C programmer, this is how they do things. The people who wrote Go, they really liked the C programming language. Like they clearly very much liked it. And they modeled a lot of the language off of it. So clearly a lot of it was drawn from there. So, unlike in these other two, where you kind of use the commas to sort of just kind of attach things together so you can make one big string, Printf has a different approach. Instead, what it does, I'll put it right here in the middle, what it does is you can still have the string literals, but basically everything is one big string literal. There's no choice but to make everything a big string literal for the first part of it. So you would say, hello world, space, my name is Matt. Okay, you could do that, and that's fine, right? But now let's say I wanted to put sumnum in here. Well, I can't do that, right? Because now I'm still between these two quotes. So it thinks I want to actually just print the word sumnum. No, I want to print what's the value of this. So the way you do that is you have special little codes you use. I know that sumnum is an integer. There's a special little code for when you want to print an integer. You do %d. And that's how it knows that there's going to be a number that's going to show up here. And then after the whole string is done, at the very end, you put whatever the variable is that's going to be replaced. The value of this is going to show up here in the string. So by setting it up this way, it will look exactly the same as I did on this one and on this one. Well, really on this one, because I have spaces in there. All right, so let's see it. Oh, I forgot to put, and look, I didn't put a new line at the end. See? No new line, so I got to put the new line at the very end. Yeah. Hello, 42, my name is Matt. Hello, 42, my name is Matt. Now let's say I wanted to move that decimal, right? So all I have to do is move this somewhere else. Maybe I'll put it there now, right? And just by moving that D, that's just telling it where the number is going to show up now. Now it's hello 42 world, my name is Matt. Yeah. So this is just a way a lot of people like to format their output. They'll use Printf because they feel like they have more control. Personally, I don't really like it. I don't find it overly valuable for our class. I think it just adds complication. Also, you got to go learn all these little symbols, So there's a different symbol for every single data type that you're going to try to print. So for instance, this works only because this happens to be an integer. But let's say I wanted to add, oh, I don't know, a string to the front of this. I'd have to say %s space, right? But since this is now the very first thing that's showing up in the printf, the very first variable that I have to put over here is some kind of a string. So maybe I put the string here now. The string, right? So now what I'm telling it is the first thing is a string. So go over to the very first thing here and replace that with this. Then start writing the rest of this. When then you get to this part, replace that with this. And then you just have to keep track of it. So the order matters. The order that you actually put those symbols in there relates to the order that you append all of these things at the end of the printf statement. And hopefully you're seeing why it gets a little confusing. The string, hello, 42. See, it did it. It worked. It's kind of a pain in the butt. So you have to end up learning this, and then you kind of have to keep track of the order. Again, I just don't personally like that very much. This is literally the one and only time in the class you're going to see me do it. But some people really love this. It's actually quasi-contentious how people are about this. So I don't want you to not know about it. That's how it works, but you're just never going to see me do it. Right? Pretty much the whole semester you're going to see me doing this and this. Okay? All right. Any questions about outputting data to the terminal and how that works? I want to make sure everybody's cozy with it. I'm going to check my notes while I'm doing it. I kind of glazed over it. These are functions. We're going to talk more about what a function is later on in the class. For now, I'm just trying to give you some basics. Just it's like, here's some tools to let you do some real basic stuff. Pushing stuff out of the terminal is like one of the most basic things you're going to do in any starting out programming class. So you kind of have to take it on faith at first, recognize we are going to come back to it, and then kind of explore it a little bit more and get a little bit more of an appreciation for what this part of it means, or even what this right here is, right? And what this is. We're going to talk about these things. I don't want you to get too beat up on that right now. Let's move on to something, let you actually do something before you start caring about all the little details. Okay, I'm not seeing any questions. The last thing we're going to do today, input. Okay? So, we talked about storing things, right? So we talked about how you can keep things in your program. We now talked about how you can take things that are in your program and push them out of your program. So the reverse of that now is to take things that are outside of your program and bring them into your program. That's commonly referred to as input. Now, unlike with the output, where I'm a little bit kind of free, I'm like, here, you can use any of these functions you like. It's all good, right? I'm not that way about input. Technically, in Go, there's a number of different ways that you could collect input and bring it into your program. So if you start Googling this, which you should do, if you start Googling it, though, you're going to find a lot of different ways to do that, okay? I'm going to be super heavy-handed here. I'm going to be prescriptive. I'm telling you right now, there's one way that you're going to do it in my class. When you're collecting command line input, as the program is running, if you want to collect input, there is one way that I'm going to have you do it. And so you got to do it my way. If you do it a different way, AutoGrader will, they'll tell you no. And you'll be like, but it works. And I'll be like, but you didn't do it my way. So I'm just letting you know right now, you got to do it my way. Right? So this is the part where I'm being a little bit of a stickler. Okay? So, what is that one way? Well, we're going to use another function. Okay? That function is called fmt.Scanln. Okay? Now, it's similar to Println in that you do this, and then there's something that goes in here. Okay? But now, think about this logically. When you are printing something out from your program, that information is already in your program. I wrote hello world here, right? As the programmer, I had the information and I was saying, here, other person, here, terminal, this is for you now. It started with me and now it's for you. Well, now when we're collecting something, the information doesn't start with me. It starts outside of the program. It starts outside. So when it comes into the program, how am I going to get hold of it? Where do you think I'm going to need to be able to hold that information in my program? What place do you think I'm going to put it? Hint, hint, wink, wink. Where does a program keep information that it's using as it's using it? I know there's at least 2 of you out there, so I'm expecting an answer now. It was a trick. He tricked me into participation. All right. So where is this information coming into? Where do I need to put it so I can actually use it? Because ideally I'm asking for input and then I want to actually use that input for something, right? So where does it need to go so that the program can use it? Where does it need to go? I don't know how much more heavy-handed I can be about that. It could just be that the lag is bad. Just a blind guess. Is it the RAM? Yes, you are right. You're right. Blind guess. I'm practically beat you over the head with it. Yes, it's RAM, right? And what is RAM? For our program, how do we interact with RAM? We interact with RAM through variables. Because variables are just a symbolic thing that represent a spot in RAM. That's all a variable is. It's just a symbolic thing that we create in our programs that literally means an address in RAM. That's all it is. So whenever I say this, you need to put something in RAM, what I'm really saying is you need to have a variable, right? So if I want to collect information from the outside world and I want to put it into my program, I need a variable to store the information that I just got. So let's do it. I'm going to create a variable that can hold an integer. All right. So I'm going to collect an integer from the user. So I'm going to say var user int integer. Right. Now I'm going to use fmt.Println, which I just talked about a whole bunch, and then I'm going to prompt the user who's using my program to enter something. Please enter your favorite integer. Okay. After that, I'm going to use Scanln to collect that information. So this is going to print to the terminal, and then the user is going to go, oh, I got to type something in. And then they're going to type something in. And that information, you might think you just do this, right? This seems very natural. I'm going to put that information into the variable I just declared. And that is a very reasonable, completely reasonable thing to do. So here we go. I'm going to go fmt. And then at the end, after I've collected the information, I'm going to say is user int, right? Okay. So this seems like this should just be fine, right? Created a spot to store it, prompt the user, collect the information, and then I'm just going to tell them this is what you typed. Right? Seems very reasonable, doesn't it? Whoa! I keep saying that so you know that it's like something weird's gonna happen now, right? So here we go. Go run input.go. Please enter your favorite integer. Your favorite integer is 0. I didn't even get to type anything in. It didn't let me type. It made false assumptions about my favorite integer. Okay. So what's going on here? So the reason you got 0 is because remember I told you that every primitive data type has a default value? Well, 0 is the default value for integer. So basically it's almost like it just blazed right past this. And that is kind of what just happened. So I'm going to say this. I'm going to zoom in really deep so everyone can see this really super duper, like overkill time. Okay, right here. When you get to this spot right here. So this is fine. But every time you use Scanln, you must put an ampersand before the name of the variable you're storing it in. Right? You have to put an ampersand there. If you do not put that ampersand there, you'll get exactly what just happened to me. It'll happen to you too. Right? It'll blaze right past it. Nothing will happen. You'll be like, why, what, huh, who, right? So always remember to put the ampersand right before your variable when you're using Scanln. Okay? Now, get back to a reasonable size text, right? Now that I put the ampersand there, let's see what happens. Please enter your favorite integer, 42, obviously. Your favorite integer is 42. There it was. Okay. So notice that it printed this first, and then when it got to this line, it paused. The program just basically sat there and waited. Okay. Now we'll talk more about this, but what it's doing is it's trying to read information from the input buffer. The input buffer is just like there's an output buffer where information goes from that to the terminal. There's an input buffer. The input buffer is where the operating system puts the information that it collected from the keyboard, and then your program can read it out of there and into your program. Okay? So that's what Scanln is attached to. Scanln is attached to that input buffer. It's reading the information out of there, and then you just need to tell it which variable you'd like it to move the information into. Right? And that's what I did. So I told it, they're going to give you a number. Put the number in this variable, which ultimately is a specific spot in RAM, and that's how I'm going to keep track of it. I'm going to use this symbol to represent that for the rest of my program. And after it's in there, then I can do whatever I want with it. Then I printed it out here. Good times, right? It's been a long day. Okay. Any questions about Scanln, how it works? Wait a minute. Make sure everybody's cozy with everything that I've done. I think we're good. Feeling pretty good. Hopefully, today's a little bit of drinking from the fire hose. I'm giving you a lot. It's a lot to chew on. All right. I'm going to just repeat this because it's worth repeating. You have to use this, okay? I know some of you are going to Google it and you're going to be like, oh, I found a different way. Yeah, it's not going to work. You need to use this. This is what I'm expecting you to do. For output, you can kind of do whatever you want, right? For input, you got to do it my way. I promise you this, by the way, this is not the only way you're going to collect input in the class, right? For a large portion of the class it is, because for these first number of weeks, you're just going to be kind of learning some basics. And so I just need there to be a nice standard way for everyone to do it. I don't want to have to deal with like the 10 different ways you can put the input in there. I want us all to be kind of doing the same thing. That's the main reason for it. Not because I hate the other ways. But there are going to be some other ways that we can do it that are more for when I introduce new concepts for how to collect other input. Everything always makes sense in lecture. It's during the assignment when questions arise. Well, that's just the way it goes. That's okay. I'll use that as a little jumping off point to say, use Piazza, okay? And that's why I have it up there. Please, please, please use it. You will not regret it, and there is no such thing as a dumb question. So if you're doing your assignment, you run into a problem, you can't figure it out on your own, Piazza is your go-to place for it. And I will give you all this code. Okay, this is just yours for the messing with. Let's venture away from all this. Let's head back over to Canvas, and I'm going to use the last little bit of time we have to talk about the upcoming homework for the week. These are the new assignments you're going to have. There's a lot going on here. There's a lot. I'm going to walk through it right now, but there's a lot going on here. So, don't wait till the last minute. This is a terrible idea. I see a lot of students do it. They wait till Tuesday. They think they're going to come in here and just bang it out in like a 20 minutes or something, and then they end up being in deep doo-doo because then they start freaking out on Tuesday, posting everything in Piazza on like Tuesday at 8 o'clock. I'm not looking at Piazza at 8 o'clock, and then they probably aren't going to get a good grade, and they're not going to like themselves very much the next day. So start early, hit the brick walls early. Post your code, post your questions in Piazza early. I and others will help you. Life will be much easier for you if you do that. Let's talk about personal factoids. Okay, so this is the first of the homework due on Tuesday. The point of this programming exercise is literally just to get you to practice using FMT print or printf or println. This is just output. I'm evaluating whether you know how to put things onto the terminal with all that stuff I was just talking about, right? And the way I'm having you do that is you're going to basically create a program where I want you to output some information about yourself. You're just sharing a little something about yourself. This is only going to me. It's not going to everybody else. If you want to put completely nonsense information in there, I don't really care. You know, if you don't feel like you're comfortable telling me your favorite food and you want to tell me something that's a lie, how would I know? All right. So the main point here is I want you to know how to format the output. My programming assignments, pretty much every single programming assignment I give you in this class, the directions will come with this example output. Okay. The example output is me telling you exactly how the output should be formatted for your program. It is not a suggestion. It is not like something that you can kind of like, oh, maybe something like this or close enough. No, AutoGrader will expect your output to look exactly the way that I have prescribed it. And if it does not look exactly the way I've prescribed it, AutoGrader is going to tell you, and you're going to be like, darn it, it's too picky. Well, programming is a very specific skill. It's very important that you kind of get that going early on, in my opinion. Like, it's not a game of horseshoes. Close to the pin isn't really going to get you any points, right? And there's many times when you're writing programs, if later on, get further on in the thing, you're writing programs that are going to communicate with other programs, right? Those other programs, they don't like see like close enough. If you tell it, I'm expecting the information I'm passing from one system to the other to be formatted a very specific way, it's going to try to read it in a very specific way. And if you put the comma in a slightly different spot, or you put the uppercase in one spot, or you added a bonus space for no reason, it's not going to work, right? So I'm just trying to get you to do good habits. So you're going to see this every time. So this is kind of your guiding light for how to implement that stuff. So what I'm expecting from your program on this is name, space, your name. Next line, favorite fictional character, space, your favorite character. New line, right? Exactly the way this is set up. Notice how there's two new lines here after Star Trek or Star Wars. You're going to tell me whether you like Star Trek or Star Wars. I will judge you. And then you're going to have a new line, and then you're going to have another new line. If you don't have this extra new line, AutoGrader is going to tell you that, right? Then favorite quote, this better be there, right? After that, this can be as long as you want it to be. It can be as many lines as you want it to be. Doesn't matter, right? But this is the format I'm expecting, right? A lot of this assignment is very, very nitpicky. That's what I'm trying to get you to do. Oh, we got some comments in here. What was last night? You started last night? Good on you. Excelente. Didn't like your submission? Yeah, that's how it goes, right? But you started it early. You know what it is. You got feedback. Hopefully that feedback's helpful. If it's not, then I would put that feedback into Piazza. You're probably not the only one who's going to have that thing that it didn't like. And then you'll have got the answer, and you might very well have helped somebody else out on the journey. So, thumbs up to you for getting going early. Input number, output number. I basically have done this assignment for you. This is pretty much what this was, right? I mean, you input a number and you output a number, right? There's only one part of it that's a little different, so I'll let you go figure that out, right? And this is the part where I want you to do a little of your own personal research on how to implement something. It's something I didn't actually cover in class today, so you are going to have to do a little bit of your own research. The point of this is this is really just testing whether or not you know how to do input and output, and then also declare a variable, right? So it's kind of the other things we covered today. I also, for the example output, this is usually the format I have it in. Make it really clear. Here is your example output. Again, it should match this exactly. All right, the format should be this exactly. Oh boy, what just happened? What in the holy moly was that? All right, Edge, you're getting a little big for your britches here. I'm going to start having to go through the settings and start changing things. It's doing this weird stuff lately, and I'm like, it thought it was like, we have ChatGPT, we can do whatever we want now. Like, no, you're still like not really my favorite my favorite browser. Like, stop doing this. Um, I want this to be the first line. Whenever you see example output, I always usually put this in there. If I'm if the program needs to collect input, which most of them do, right? In the example output, I will bold and underline the parts that are actually supposed to be input. So for instance, in this particular example, right, I'll move in a little closer here. For this example, right, your program output should be this, and then it should wait for the user to enter something. For example, the number they could put in is 42. That's just an example. This is an example of the input. Notice how it is bold and underlined? That is me telling you that this is an example of something that they could type in. If the user typed in 42, then the rest of your program should print out you entered 42. Twice that value is 84, right? So I'm giving you like an example of how the program should look, but I'm also providing you an example input. When I test it, when AutoGrader tests it, it's probably not going to use 42 here. Your program should work with regardless of what number I put there. I could put, I don't know, 5,000 in there, and your program should still work. It should still print out the appropriate number here and the appropriate number here. Okay, so that sometimes tricks people up. I just want to make sure it's very clear what I'm trying to do there. And this is going to be the case for many programs. Most programs will have input. So that's just how I differentiate between output and input. I didn't mention this on the last one, but of course, always review the grading rubric. This is telling you exactly how you're going to be graded. Right? This is exactly how AutoGrader is grading you. This is all the things it's looking at. So it's going to make sure you have the proper code layout, which we talked about earlier, right? It's going to make sure if your program compiles, it's going to give you 20 points, right? If you collect the input the way we talked about today, 35 points. If it has the correct output, 35 points, right? This is how it grades. Last thing. No compile Kyle. Okay, so this is, there'll be a series of these. I have a number of no compile Kyle assignments throughout the semester. So no compile Kyle is a fictitious person, fictitious programmer who I have made up, and he's a really swell guy. He's a sweet young man, aspiring to be a programmer like many of you, but despite all of his best efforts, despite how hard he tries, he just cannot seem to write syntactically correct code. Can't do it. Go is just too hard for him. So, your job will be to take a look at his very crappily written code and fix it. Your job will be to take his code and fix it. You'll get a bunch of these, a number of them throughout the semester. The point of these assignments, the no compile Kyle assignments, is to kind of reinforce what I was talking about earlier. If you're going to be a professional software developer, you're going to spend a lot more time looking at other people's code than your own. So this is my kind of baby step way to get you there. So it's going to get you comfortable with that idea of looking at code that you didn't originally write. It's also going to force you to kind of get cozy with Go's syntax. This isn't a Go class, but we are using it to facilitate things. You're going to need to know the syntax, right? Kyle's code is not syntactically correct. So by correcting his mistakes, it'll reinforce what the correct syntax, what Go's expecting it to do. Hopefully that'll help you out. Last thing that it does is also something we talked about today, and that has to do with commenting. Kyle he's not a good programmer. He's a terrible programmer. However, Kyle's a pretty good commenter. He actually writes really decent comments. His comments pretty clearly outline what he's attempting to do. He's failing at doing it, but you kind of know what he's doing because he documented his code, right? So this is another way for me to showcase to you the importance of documentation. Because despite his program being crappy, right, because his comments are pretty good, it usually is it's a lot easier for you as the person coming in to clean up the mess to know what he was trying to do and then implement it correctly. Okay. So the way you're going to do it is you'll click on this little arrow down button, right? And that will let you download his code. Okay. You'll download his code. You're going to want to move that into your text editor, or you can just copy it after you downloaded it and paste it into REPL, whatever you want to do, right? Then you're gonna read what his attempt does here. Again, here's some example output. I gave you a couple different example outputs in this case, right? So in this case, here's what the program should look like if you ran it with 1.2 and 2.5. It should be this output. Here's an example where you ran it with the input of 10 and 5, and this is the output you should get, right? So I'm giving you, so I oftentimes will do that. I'll give you multiple examples so you get a sense of what it could look like. And for me, from my perspective, what would be the smart thing for you to do here, once you get your program running, I would run your program and I would punch in these values. Because here you are, you have you have something to test against, so you know exactly what it should look like. And you can do all this long before you ever get to AutoGrader. AutoGrader should really just be the last step. Like, I'm pretty sure this works fine, everything's great, time to go to AutoGrader. And at that point, hopefully the only thing AutoGrader is going to say, well, hopefully it just says 100%. But if you don't get 100%, I'm hoping that the thing it's wrong is like, oh shoot, I didn't have a capital character somewhere, or extra space or something. It's something stupid that it'll take you like 2 seconds to fix. Hopefully, that's what I wish. Doesn't always work out that way. Is there anything else? I think that's it. Those are the 3 main assignments for this next week. And then, of course, the command line quiz. So this is our first quiz. I actually didn't give you guys one last week. You've now, by this point, you should have watched my command line video. This is a quiz to kind of help you reinforce that, to let you know if you've gotten it down, just quiz your knowledge. Most quizzes, almost all quizzes that I give in this class, you're allowed to take it one time. And whatever you did that one time, that's your grade. You don't get to take it multiple times. This is the only quiz that is not true. You can take this quiz as many times as you like. You can just keep on taking it until you get 100%. It's that important that you actually understand the command line. Right? So take the quiz. If you bomb one, look at the answer, retake it, get 100%. Maybe watch the video again if you didn't get 100%. But that's the idea behind it. All the other quizzes you can only take once. So I'm just making that clear. Any last minute questions? And kudos to all of you for sticking in there. No, these are long videos. They're long for you. They're long for me. But the value here is that you can rewatch them later if you'd like. All right. I don't see any questions. I think we're good. Have a wonderful rest of your week. It's only a few days left, right? Get started on the homework, and we will meet again next Thursday, 1:30, same bat channel, same bat time. Until then, adios.